Hello, everybody. So in today's module, we're going to discuss renewable energy. And along the way, I will try and explain a few concepts and technologies that can help us understand renewable energy better. To get started, let us understand what energy is. In its simplest definition, energy is the ability to do work. Okay, so work can be anything like moving an object from point A to point B. So moving this phone from here to here can be considered work, or it can be something as complicated as sending a satellite to space. To understand this more, but further to kind of comprehend it, let us look at the human body. Work for us could be anything from walking, talking, and playing. And the energy to do this comes from the food that we consume. So, in this example, food is the primary or the first source of energy that our body, that can be considered a machine, processes through chemical and biological processes and then converts it into energy that we can use to do our everyday tasks and grow. So energy like this is converted around us in the world. For example, plants use the energy from the sun to do photosynthesis, to make their own food and to grow themselves. So if you notice in these two examples, energy was never created and it wasn't destroyed. It was only converted from one form to another. In the first example, the chemical energy from food gave us the energy to say cycle or to move, right? And in the second example, energy from the sun was used by plants, converted to chemical energy for their own food. So say it with me again. Energy can neither be created, it cannot be destroyed, it can only be converted from one form to another. Now let's talk about electricity. What is electricity? Electricity is the energy required to power all the electrical appliances in your house. The refrigerators, the air conditioners, the computers, and even your Wi-Fi requires electricity. And the first example of a little district being electrified can be found in 1882 when Thomas Edison, the same man who discovered the light bulb, switched on the electricity generating station in Pearl Street Station, New York City. Can you see this example here? He used two incredible machines called turbines and generators that we will study in the next slide. But before we move on to that, I want you to look at this little graph. This little graph that starts from the 1800s to all the way till today. And as you can see, the red line indicates the population growth. Okay, and the blue line indicates our energy consumption. It has grown at the same rate that the population has grown. And this indicates that we are very much dependent on energy. You don't need to look at this graph to understand this. Do you remember the last time there was a power cut? Do you remember feeling helpless? This is what I mean by we are extremely dependent on energy for our everyday tasks. So electricity. So before we discuss, before we move on to types and sources of energy that we can convert into electricity, I want you to quickly run over turbines and generator. These two incredible machines that Edison used to generate electricity. Now, a turbine is this round structure that looks like almost like a wheel. And this tends to rotate when air or water moves through it. Now, when this rotates, this attached rod-like structure can transfer this rotary motion to a generator. And the great thing about a generator is that it converts this rotary motion into electricity. So the turbine captures any moving energy to rotate. And with the help of shafts and gears, this little picture that you see here, it can transfer it to a generator, which converts this rotary motion to electricity generation, which is then supplied to our houses. Now, shafts and gears might be confusing, but these can be found in your cycles, and small versions of it can be found inside your watch. So like I told you, there are several sources of energy around us in the world, right? And we have learned to convert them to electricity because we are brilliant. Humans are brilliant, right? So the most common source of energy that is used for electricity generation, the same source that Thomas Edison used back in 1800s, are fossil fuels. Now, why are fossil fuels called non-renewable sources of energy? To understand this, we need to understand how they were created. So these were created more than 250 to 350 million years ago when plants and animals died and they fell on the land or on the ocean bed. Then more plants and animals died and they collected on top of that. And then the heat and pressure from inside the earth converted the fossils of these plants and animals into fossil fuels. This is why they're called fossil fuels, because they were created from the fossils of plants and animals that died millions of years ago, even before the dinosaurs. So what Thomas Edison did in his brilliant steam turbine and generator back in 82 was he burned these fossil fuels. When he burned these fossil fuels, they released tremendous amount of heat. And this heat was used to heat boil water. And when you boil water, what happens? The hot air rises. And this rising hot air was used to turn the steam turbine. I'm going to take you back to that picture. So this, as hot air rises, it falls onto the turbine and the turbine rotates. The turbine, with the help of shaft and gears, transfers this rotary motion to a generator, which can convert this to electricity. This is what he did back then in 1882. And even today, we burn fossil fuels and use turbines and generators to make electricity or to generate electricity to power our houses. But here's the thing. Over the years, we found that when we burn fossil fuels, they release a lot of waste. Just like, think about us, when our body undergoes these biological and chemical processes to process the food, we release waste too, in the form of carbon dioxide or the reason why we go to the restroom. Right. Similarly, when fossil fuels are burnt, they release gases, they release particulate matter, they release ash. All of this kind of goes into the environment. So particulate matter and ash that collects around us at our eye level is what causes air pollution. The air pollution that you see in the winters in your cities? Yes. Whereas climate change is when gases like carbon dioxide or emissions like carbon dioxide rise, look at the second picture, rise further into the atmosphere. They tend to collect on the outer stratosphere. As they collect here, they prevent the heat from escaping the Earth's atmosphere. So it becomes hotter, and as the Earth becomes hotter, it tends to change the climate patterns. So this is not something you see as evidently as air pollution. It's something that happens over years and years. And the first person to suggest this was a guy called Guy Calendar in the 1880s, who said that carbon dioxide released from these burning of fossil fuels could change the temperature of the Earth. Okay? And several scientists since then have come out and said that carbon dioxide and along with other emissions can actually heat the atmosphere and change our climate. There is proof for it. Finally, in 2015, 192 countries came together and they signed a pact that said that climate change was dangerous for us humans. It was destroying the planet for future generations. And to help and control this, we need to reduce our emissions. They also agreed that most of the emissions were because of the burning of fossil fuels, which is how humans derived most of their electricity and most of their energy. Now, can you imagine giving up on fossil fuels? Can you imagine giving up on electricity? This is not possible. Thankfully, we along the way have discovered several renewable sources of energy. Now, what is renewable sources of energy? Now, these are found abundantly in nature and they do not deplete on use like the fossil fuels do because they're constantly regenerating and reproducing. This is why they're called renewable sources of energy. More importantly, they're clean sources of energy that do not pollute or impact climate change. So there are several types of renewable energy sources out there. Today, we will talk about a few. So let's get started. Let's talk about solar energy. Solar energy is the energy from the sun. This is available to us both as heat energy and as light energy. Okay? And we have found out specific machines to help harness these two different types of energy. The first is heat energy. The heat energy from the sun can be used directly, okay, to heat space, water, or air. You might ask, how? I would strongly suggest that you guys try this experiment at home where you try and make a solar cooker at home. But the basic principle is that if you use lots of mirrors, okay, to redirect the sun's heat to a singular point where it can be concentrated, the collection of heat is enough to heat water or air. Do you understand that? So mirrors, so in your solar cooker, the silver foil wrapped structure works as a mirror. So it redirects the heat of the sun into the solar cooker, helping you cook. You can boil your eggs through this. Now, the second way to harness the energy from the sun is with the use of solar photovoltaic cells. These use the light energy from the sun. Photo means light, voltaic means electricity. So they are made up of something called semiconductors. What are semiconductors, you ask? To understand semiconductors, you need to understand what a conductor is and what an insulator is. Conductors are materials like copper wires. The copper is used inside your wires that help transfer electricity without any friction. Right? They transfer electricity easily. Whereas insulators are materials that cannot transfer, that do not transfer electricity easily. So these are materials like rubber that is wrapped around your wire. This makes sure that the electricity passing your wire does not shock you. Now, semiconductors are basically in their natural state insulators. That means they do not transfer electricity. But when they are hit with light energy, they transfer electricity just as any other conductor. Okay. The most commonly used semiconductor is silicon, what you see in sand. Okay. So the semiconductor forms a photovoltaic cell. Several cells together form a module. Several modules together form a panel, like the panel that you see on top of houses and on buildings. And several panels together form an array. Several arrays together form a solar power plant that you see in this picture here. The largest solar power plant is in India and covers a space of 53 square kilometers. That is equivalent of thousands and thousands of football fields, one after the other. Isn't that great? The next energy that we're going to talk about is wind energy. Wind energy is the energy of blowing air or wind. So how is wind created? Let's quickly go over how is wind created. When the sun heats the surface of the earth, the land tends to heat faster than the water or heats at a higher temperature. This is because the land reflects the water, right? So it is getting the air above land is getting heated by this direct solar radiation and it is getting heated by the solar radiation that was reflected from the surface. Now, as this heats, this rises. To understand this, think of boiling water. As water boils, the hot air rises, right? Similarly, the air over water body also receives heat from the sun, but a lot of it is absorbed by the water. So this tends to be cooler than the air on top of land. So when the hot air over land rises, the cool air from the water body moves in. This blowing air is called wind. If you notice, the last time you were on a beach or you were next to a riverside, you must have felt the strong winds, right? So the first application of wind energy is as much as 2500 BC, when humans in East Asia used it for sailing. So you know what happens in a sailboat? When the wind blows, the sail captures this energy of the wind and then converts it to energy that can help move the boat along. Think again, this was used in 1500 to 1500 BC. Now, these windmills that you see here use a very similar concept, but they were first discovered in 400 BC. So if you look at these windmills, they've got these blades that make it look like the turbine you saw earlier in this module. So when the wind blows on them, these turbines rotate. To understand sort of windmills that were used in 400 BC and later, You can try this simple experiment where you create a handmade windmill, attach it to a straw, tie a string at the end of it, and a paper clip at the end of the string. When the wind blows and this rotates, so does the straw. As the straw rotates, the thread wraps around the straw, lifting this load. So this principle was applied along with windmills to lift water out of the wells and to pick up heavy loads such as stones for like building, for building a house or something along those lines. So like I said, this sort of a windmill, when combined with a generator, can generate electricity. That is a concept of a wind power, where blades are rotated because of high winds, and then this rotary motion is transferred to a generator, which can generate electricity. Now, since the first wind turbine was discovered, we have found out how to make them bigger and larger so they can capture more wind energy. We have also figured out how to put them over water, right? And these are called offshore wind turbines. The next type of energy that I want to talk to you about is tidal energy, or the energy of falling or flowing water. Now, tidal energy is of two distinct types. The first is the reservoir type. In a reservoir type, a dam is built. As you can see, these are the dams, and they help collect water behind them. So when electricity generation is needed, this water is allowed to fall onto hydro turbines that are typically stored at the bottom of the dam, right? When these turbines turn and along with the generator, they can generate electricity. Typically, this water falls on these turbines and then is allowed to go downstream as per the path of the water, or you can use the same water collected at the bottom, pump it back up into the reservoir, and then reuse the water for generation again. The second type. So the reason for the second type, or the run-of-the-river type hydropower, is sort of better is because in the previous type that we discussed, the reservoir type, the water is collected in large areas like this. But in the case of heavy rains or floods, this water can go into the surrounding areas, which might be farming areas, places where people live, and could displace them. So there is that environmental consequence. In the run-of-the-river type hydropower plant, this does not happen. So in the first type, what you do is you set up hydro turbines along the path of a flowing river, and as the water flows through it, it generates electricity with the help of a generator and can be sent along. No water is stored, water is just allowed to go along its normal path. Okay. In another type, what happens is for a lake that is flowing downhill, they redirect the water with the help of channels and canals, and then with the help of penstock, let it release over a hydro turbine and generator. And once the water is used for electricity generation, it is released back downstream. Do you see? There is no collection of water. There's redirection and there is normal flow. The last type of energy that I want to talk to you about today is geothermal energy. Geo means earth, and thermal, like I told you before, is heat. So geothermal energy is the energy from the heat inside the earth. As you know, there's a lot of hot magma inside our core, and this heat is transferred through the many layers of earth. So just as the heat from the sun can be used to heat space, water, or air, so can geothermal energy. But you know what? This heat can also be used to generate electricity. So let us look at geothermal heat pumps. Okay, so geothermal heat pumps are basically a set of pipes, okay, that run from your house, okay, to the ground where the temperature is hot. So imagine a very cold day. The water in its ambient temperature is really cold, right? So this is pumped underground where it comes in contact with the heat of the earth, right? And this heats the water. This hot water is pumped back up. This water, with the help of a heat exchanger, can transfer the heat to air. So it cannot just heat water for you, but can also heat your house or a building. This heat can also be used for cooking. Okay. The second type of geothermal use is geothermal electricity, where the heat from inside the earth is used to heat water, which creates steam. And then steam goes into the steam turbine, which rotates. And then with the help of a generator, it generates electricity. The same principle as used in fossil fuel plants, but there is no burning here and there's no release of emissions. More importantly, the hot water is not just let out, it is cooled with the help of cooling towers and sent back into the ground to be reused. So these are 4 types of renewable energies that I quickly covered. There are several more, and there are 3 that I want to bring to your attention. The first is biomass energy, okay, which is the energy from dead plants and animals, but not fossils, right? So they, again, are used to heat water, steam, turbine, generator, generate electricity. The next is ocean energy. And in the ocean, there are 2 types of energy that we can harness. It is the energy of the wave, which means the trough and the crest of a wave, okay? Or it can be tidal energy, the high and the low tides can be used. As you can see, we have discovered several types of ocean turbines that can be used to generate electricity. The last and the most exciting for us right now is hydrogen. So when we create a fuel cell, in a fuel cell, the hydrogen can combine with oxygen. And do you know what it releases? A, it generates electricity. B, it releases water. Therefore, 0 emissions while you generate electricity. This is a relatively new technology and almost as expensive as solar cells were in the 1950s. But we can't wait for this technology to become everyday, to come into everyday use. I urge you to go look at the different types of renewable energy and understand them better and learn more about them. These are essential to help save our planet so that you can grow up in a cleaner planet. Thank you, everybody.